right, let's get into today's converse of Pythagoras. So when we did geometry, we spoke about this idea of a converse theorem and the fact that if the theorem of Pythagoras is true, so if we know we have a right angle triangle and can therefore work out sides, the opposite is then true, in that if I have all sides of a triangle, I can then prove whether or not it's a right angle triangle. And that's essentially what the converse of Pythagoras does. Okay, so the converse theorem of Pythagoras says that if we have all three sides, I don't know if it'll be easy for me to type this. I don't even know. That's where I'm at today. Let's just write it on the letters. So if we have, all three sides, we can try prove the triangle's right angled. So basically, the converse is used to prove whether or not a triangle is a right angled triangle. Okay, that's what the converse does for us. We know that Pythagoras works with right angled triangles, so we can go the opposite way and prove the triangle is right angled. Now, guys, a really important thing to remember, and it's something I've mentioned to you before, it's something that I mention every time we do a Pythagoras question, is the fact that the longest side of a right angle triangle is your hypotenuse. Now, this is obviously important to know, because if we're going to use the Pythagorean formula, hypotenuse squared equals to side 1 squared plus side 2 squared, we have to know which side is the hypotenuse. So really, really importantly, your hypotenuse is always going to be your longest side. Okay, so when we start to do these proofs, this is something that we need to remember. So let's put this into practice. So we'll have a look at this first one together. We'll deal with any issues you have, and then we'll move on to more examples. So we've been asked to prove that triangle XYZ is a right angled triangle. So the first thing that we want to do is we want to determine the longest side. Okay, so on the chart, tell me which side is the longest side. Nice, guys. Okay, so there's two different ways you could actually answer this. One way is to tell me that it's side XY. Side XY is 20 centimeters. Now I know that because obviously 20 centimeters is the longest of my three sides. Once I know which is my longest side, I can now apply my Pythagorean theorem. Okay, so use Pythagoras or Pythagorean formula. And just as a reminder, I did say it earlier, but just to write it down for us, this is the hypotenuse squared is equal to the sum of the square of your two other sides. Okay, you need to know the Pythagoras theorem. We don't give it to you. You need to know that information. Right, so we're going to substitute into that formula. So the longest side is your hypotenuse. So that would be the 20 squared is equal then to the sum of your two other sides squared. It doesn't matter which side you put first. So if you had said 12 squared plus 16 squared instead of 16 squared plus 12 squared, doesn't matter, does not matter. Now guys, what you can see is that you're not actually solving for anything here. You've substituted in all values. So to prove it's right angled, we want to prove that this equation is essentially true. And when we say an equation is true, essentially what we're trying to do is we're trying to prove that the left-hand side of our equation is in actual fact equal to our right-hand side of the equation. That is how you prove an equation is true, or how you show that an equation is true. So if we can do that, we can show that it's a right angled triangle. Sorry, I just want to move this up, otherwise I'm going to run out of space. Okay, so we've substituted in. Essentially, all we actually want to do now is show that the left is equal to the right. And in order to do that, we now obviously have to work out our values. So 220 squared is 400. 16 squared is some value, 256. And 12 squared is 144. We want to add the two numbers on the right-hand side to see what we get, and we get 400. Now, what we have shown is that the left-hand side is equal to the right-hand side. So what we can now say, because they are equal, that therefore triangle XYZ is a right angled triangle. And because we know that your hypotenuse is always the longest side, we know that angle Z, so the side opposite your hypotenuse, is where the right angle would sit. Okay, so the converse of Pythagoras allows us to prove whether or not a triangle is a right angled triangle or not. If this step, let me just grab a highlighter to do this. So if this step over here had been 400 equals 392, that's not true. 400 is not the same as 392. And so then our left-hand side would not be equal to our right-hand side. And then our triangle would not be right angled. We will do an example where we don't get a right angle, but just to give you an idea. So if you can show that your left-hand side is equal to your right-hand side using the Pythagorean theorem, then you have proven that your triangle is a right angled triangle. Okay, so guys, I know that's a lot of information, so take your screenshots. If anyone has any questions, now's the time to raise your hand and ask. Otherwise, like I said, we're going to do more examples and we're going to keep practicing this. Now, guys, this doesn't come up a lot, but it is important to know how to do this, because if you do need to prove something is a right angled triangle, you need to know you can use Pythagoras. Okay, so as Zimi said, in order to know it's a right angled triangle, the left-hand side should equal the right-hand side. Exactly. So like I've written here in the purple, once you've substituted in, you want to show that your left-hand side is equal to your right-hand side. If they are, so here 400 equals 400, it is a right angled triangle. And obviously, guys, you can go and check this. So now that you know where your hypotenuse is, you could go backwards and work out your hypotenuse to make sure you get 20. So if we say it's 16 squared, plus 12 squared, we get 400, and the square root of 400 is 20. That is the length of the hypotenuse. So you could double check yourself then using Pythagoras as normal and make sure that you do actually get the side length of your hypotenuse. But that's exactly what I mean. Related to any other questions, like I say, you're welcome to raise your hand at this point if you do have questions. Otherwise, I'm going to move on to the next example and hope that you've all screenshotted like I asked you to. Alrighty, I'm moving on. So last 10 seconds to take your screenshots if you haven't already. Okay. So there's a whole bunch of questions to this one, but we're going to start with this one. We want to show whether or not these triangles are right angled triangles. So we're going to do exactly the same thing. English. The first thing that we want to do is we want to identify the longest side. Okay, so the longest side in this case is 26 meters. Okay, now importantly, guys, we don't yet know if it's a hypotenuse because we don't yet know if it's a right angled triangle. Once we've proven it, then we can say it's the hypotenuse. Right now we've got the longest side. Okay, so We know where our longest side is. We're going to then use that because we know that if it is a right angle triangle, the longest side will be the hypotenuse. We can now use that in our formula. Alrighty, so hypotenuse squared or longest side squared, so 26 squared is then equal to my two other sides squared and added together. So 10 squared plus 24 squared. I didn't put a reason in this last one. So your reason, guys, converse Pythagoras, because you're going backwards to prove it's a right angle. So my reason here, converse Pythag. Please can I just remind everyone that the questions asked need to pertain to our lesson that we're currently on. Anything else you need to go back and see if there are videos on that topic. We are focusing on Pythagoras right now. All right, so we need to check that the left is equal to the right. So 26 squared is equal to 676. 10 squared is 100. 24 squared is 576. So 676 is equal to 100 plus 576, which is 676. We can see that our left-hand side is equal to our right-hand side. And so therefore we can say it is a right angle triangle. Alrighty, so because we've shown left equals right, we have shown it's a right angled triangle. Again, if it wasn't, then you would need to say that it's not a right angled triangle. Is it fine if we use a different method? I don't know what your different method would be. If you want to raise your hand now and explain to me how you've done it, you can. As long as you're, like Yolanda says, as long as you show everything and mathematically everything's correct, it should be fine. Yeah, so guys, screenshots, if you have any questions, please do ask. Otherwise, I'm going to move on to the next one, which you're going to try by yourselves. Do we have to write the fourth thing? When you say the fourth thing, I'm assuming you mean this left-hand side equals right-hand side. Yeah, we do need to write that because that's what we're trying to prove. So because we've proved that, we can now make this statement. So yes, we should write left-hand side equals right-hand side. You'll see you use this a lot more as you move up in maths. This whole proving left is equal to right. Okay, guys, so second question, I'm going to leave the first one up just so that you can see the steps that we've done. What I want you guys to try is the second one. I'm just going to help you. For the first little bit, if we identify our longest side, that is the 15 centimeters over here. So given that you now know where your longest side is, I don't know why I decided to become an oval, but we're just going to roll with it. You know where your longest side is. Let's try this one by ourselves. By ourselves. Words. Okay, so again, exactly as Rotila has pointed out, we have to say left-hand side is equal to right-hand side. That's what we're trying to prove. That's what we need to do in order to show it's a right angle triangle. Again, your goal, prove left-hand side is equal to the right-hand side. Okay, I'm going to give you like 2 more minutes and then we'll have a look. Let's go, my people. All right, guys, let's have a look. Oh, okay, so we identified our longest side. We then know that according to Pythagoras, we would have 15 squared is equal to 9 squared plus 12 squared. Remember your reason, converse, Pythagoras. And obviously we can abbreviate Pythag to, Pythagoras to Pythag. Right, 15 squared is 225. 9 squared is 81. 12 squared is 144. When you add 81 and 144, you get 225. So because our left-hand side is equal to our right-hand side, as all of you that answered on the chat said, it is a right angle triangle. Okay, guys, and you can draw a little triangle, that's fine. All right, so let's take our screenshots. If anyone has any questions, now's the time to ask. Otherwise, we're going to move on to another one. Okay, so Ursula has asked on the chat, if it isn't and the left-hand side isn't equal to the right-hand side, do we use a specific symbol? Yeah, so oopsie daisies, we could then say left-hand side exactly as you've put, not equal to right-hand side. That's absolutely fine. You'll see, I think it's the next one, but you'll see when we do one, I'm going to use exactly that sign, so well done. Okay, guys, any questions? Have we taken our screenshots? Alrighty. Okay, so let's have a look at this one. Ooh, okay. First things first, identify our longest side. That would be the 85 millimeters. So we use our Theorem of Pythagoras and we go see what's happening. So this would be 85 squared is equal to 84 squared plus 13 squared. Our reason, converse Pythag. Oops, let's just do that. Okay, now these numbers are not going to be nice, but luckily we have calculators. So 85 squared is 7,225. 84 squared is 7,056, and we know that 13 squared is 169. Okay, now on the right hand side, if you add those two values together, okay, you get a sum of 7,225. Left hand side is equal to the right hand side, so I was wrong, this was not one. And so it is a right angle triangle. It is a angled triangle. All right, you guys. So this one caught me out because I looked at that picture and I was like, oh, that doesn't look like a right angle triangle. Never assume, right? You have to prove it. Just because it doesn't look like one doesn't mean it's not. We have to actually go and prove whether something is or isn't what we think it is. Righty, screenshots. I hope there's no questions, but obviously if there is, by all means, let us know. Raise your hand or you can put it on the chat. But as you can see, sort of sneaking in the corner there, time for our brain break. You guys know the drill. First person to get the answer can explain it for us. Right, brain break. Weird situation I have going on here. Okay. You guys know how the brain break works. What we want to do is we want to go and work out the value of the very last equation there. Remember, first person to get it right on the chat can explain it for us. I need to get it right as well. Hope we enjoy the joke. Like I say, guys, waiting for answers. First one to get it right can explain it. I also panicking that I can't do my own brain break, but I'll check myself. Okay, let's give it a try. Remember to look out for your doubles. Very nice, well done. So if you want to raise your hand, Arian, you can raise it for us and you can explain how you got your answer. Okay. Wulila, would you like to raise your hand to explain how you got the answer? Okay, Zandile, would you like to explain how you got your answer? A little bit worried that we all just piled on there. Nice. Zandile?
Evening,
Oh. Evening, Zandile. Sorry, I had a sneeze.
how are you, bro?
I'm good. How are you?
I'm good. So,
Zandile speak us with Afrikaans. I heard some Jeffro somewhere.
So the black cat is 4. So 4 plus 4 plus 4 is 12.
Good.
So the 2 cats, 4 plus 4 is 8. So the 2 cats is 8. I don't know what this is.
I think it's a
The goat
goat.
with the a goat. Yeah, it's 18 because there are 2. Yeah, they're 2.
Good.
And what's this great thing here?
Let's say it's a raccoon.
Yeah, a raccoon. It's equal to 14.
Nice.
The raccoon, yeah, it's equal to 14. So the goat, 18 minus 9 is 9. So
Good.
9 plus 9 is 18. Yes. So the 2 cats is 8. And the gray thing is 4. So it gives me 121.
Nice. Well done. I don't know why I circled that so aggressively. I apologize. Nice. Okay. So guys, exactly 121. Remember your bod mass. Remember your like the number of animals that you have. But exactly as Andiles explained there for us. Our final answer, 121. Okay, someone said they don't get the joke. It's literally so they're saying they don't like maths puns, but then they make a maths pun. So it's just like a sarcastic, silly little joke. So it's saying I don't like maths puns, but I will make one if I halve 2. So that is actually a maths pun, and they said they don't like them. So it's just a silly little thing. All right, guys. So let's have a look at these next two. I am going to just right. So I want you guys to try A and B for me. So A, we've got a side length 27, 15, and 20. B, we've got a side length 30, 22, 11. Let's try these two. Let's see if they're going to be right angled triangles as the instruction asks us to do here. So the instruction says, show through calculation whether or not the following are right angled triangles. So we've done a whole bunch of examples. Let's give this one a try. Let's see if we can show that they're right angled triangles or not. Remember, your reason is converse Pythag. And remember, we need to identify the longest side so that we know what to substitute into our formula. Okay, so we're giving these two a try. I'm going to give you a few minutes. Obviously, I don't expect you to do it just immediately straight off your head. Remember, first thing, identify your longest side, and then you will know where you're substituting your values into your formula. Remember, guys, the whole point is to show left-hand side equals right-hand side. If it does, right angle triangle. If it doesn't, not right angle triangle. And guys, this is where you could potentially use that symbol that we spoke about earlier. You could say if they're not equal, left-hand side is not equal to the right-hand side. So you put like a cross through the equal sign, and that means it's not equal, or the sides are not equal to each other. I nearly tried to drink from my water bottle without the lid being open. Okay, now guys, remember it's LHS, left-hand side, and RHS, right-hand side. I'm going to give you another like 2 minutes, and then we'll have a look at these two questions. Remember guys, obviously if you're feeling stuck at any point, you just need to ask on the chat. I'm keeping an eye, I haven't seen any questions, but obviously if I miss something, you just need to remind me that you did ask one.
You go, my people. Let's do this.
Alrighty guys, let's have a look. So first one, we identify the longest side. In this question, it is 27. So now we know what we can use to substitute into our formula. So this will be 27 squared is equal to 15 squared plus 20 squared. Remember, if you said 20 squared plus 15 squared, it doesn't matter. So it doesn't matter if you swap the two other sides around. Makes no difference. What is important is that your longer side is substituted in place of the hypotenuse. All right, so 27 squared is equal to 729. 15 squared is 225. 20 squared, 400. So 729 is equal to 625. Now, obviously, that's not true. Those two things are not equal. So we will put a line through it, and we can say left-hand side is not equal to right-hand side. And so what that means is, oh, golly, Miss Nolly, is that therefore it is not a right angle triangle. All right, so guys, this is an example now of a triangle not being right angled and how we've gone and proven it. Sorry, my cat's standing at the door and wants to be let out. Right. If we now have a look at question 2, again, we do exactly the same thing. Identify your longest side. In this case, it's the side 30, and we substitute. So 30 squared is equal to 22 squared plus 11 squared, give our reason, converse Pythag. And we go and solve. So 30 squared is 900. 22 squared is something that I don't know. Is 484. And 11 squared is 121. So 900 is equal to 605. I did that quickly in my head. Let's just double check that addition. That's 11 squared, 605. Again, that's obviously not true. 900 and 605 are not equal to each other. So we can make the statement left-hand side is not equal to right-hand side. And so again, it's not a right angle triangle. Okay, so guys, in terms of your method, like it doesn't change whether it's a right angle triangle or not. You're still proving or trying to prove the left is equal to the right. If you come to the conclusion that they're not equal, then you have a situation where your triangle is not a right angle triangle. So both of these triangles here would be scalene triangles that are not right angled triangles. Okay, so let's take our screenshots. If anyone has any questions, now's the time to raise your hand and ask. Okay, make sure you've got your screenshots, please. I'm trying to think about a nice meaty one I can give you. Okay, so guys, what I want you to try for me is question C here. I'm going to take away question D because I'm going to give you something a little bit more challenging, but you can ignore what I'm doing. I want you to try question C whilst I'm thinking of things here. So just ignore what I'm drawing. You try question C.
Let's go, my people. We can do this, guys. Let's go. Isa, remember to make your statement.
Yeah, so guys, always remember your statements and always remember your reasons. Please, please, please.
You guys are really, really doing well. Let's keep them rolling. We are 63 of us, so we can do this. Isaiah's already done with C. What about the rest of you? Let's put those answers there.
Ooh. Sorry, just ignore me. Okay. Nice, guys. Clearly, I take way too long to make up a question. Alrighty, so let's go through C, and then you're going to try question D by yourselves. So longer side, 26. So that's what we substitute in place of our hypotenuse position. So we've got 26 squared is equal to 24 squared plus 10 squared. Converse, so we're looking to see, I apologize, Pythag. Okay, so 26 squared is sum of one value, 676, is equal to 24 squared, which is 576, plus 10 squared, which is 100. 676 is equal to 676, and so is a right angle triangle. Okay, so because the sides were equal, we can say it's a right angled triangle. Right, so guys, like I said, I want you guys to try question D for me. I don't know if it's very clear that the numbers are different, so I'm just gonna say the numbers are different. So I'm just gonna put the lengths of the sides in blue. Doesn't really matter, but just that way.
Yeah, we can see them, but yes, I think blue is highlighting it, so it's a great color to use.
So guys, I'm asking you in question D to prove or show through calculation whether triangle DEC is right angled. Now triangle DEC, if we highlight that for ourselves so that we know where we're working, is this triangle right on the end there. And it doesn't have the right angle in it. It's fairly obvious that that's the one I'm trying to prove is a right angle triangle, but it's this triangle on the far right here. I can't highlight to save my life tonight. I'm going to try that one more time, otherwise I'm giving up. Right, there we go. So I want you to give this a try. We've got 8 minutes left. I'm going to give you, say 5. Give myself 4 minutes, no, 3 minutes to go through it with you. Let us try this question DEC, triangle DEC. We do also have a poll, so it'd be great if we could finish with 2 minutes to spare. But I'll see where you're at in a few minutes, and then we'll have a look. Okay, in grade 8, when a question says prove or show through calculation, basically all that means is show all of your working out. So when we say show through calculation or prove showing all calculations, just show all of your working out. That's all we mean by that. We're not trying to be like mysterious or anything. It just means show us everything that you've done. Give you another 2 or so minutes. Oh, excuse me.
Let's go, my people. I feel like most of you are cheating because no one has given me the answers for DC, and you need DC in order to prove. No one has calculated DC so far.
Copy. Okay, guys, let's have a look. All right, so
One time.
right, so like Yolanda said, we can see that we're working in the blue triangle, and we know that if we want to prove a triangle right angled, we need all three of those sides. So we don't have DC, so that's what we need to find. If I move into the next triangle ADC, I don't have enough information to use Pythagoras to work out DC. So I almost have to start right at the bottom triangle ABC and start determining things from there. So if we start in triangle ABC, we're going to use Pythag and we're going to work out AC. Now AC is my hypotenuse. So AC squared is equal to 9 squared plus 12 squared. My reason here is just normal Pythag. I know it's a right angle triangle. I'm trying to work out the hypotenuse. So AC squared is 81 plus 144, which gives us something. 625. When I square root both sides, I get that AC is equal to 15 units. So now I know that this side is 15, and so now I can go and work out DC. So now my next triangle ADC, CD is once again my hypotenuse because it's opposite my right angle. So CD squared is equal to 8 squared plus 15 squared. Again, my reason is Pythag. And so I've got CD squared is equal to 81 plus 225. So 81 plus 225 is 306. Square root both sides. I'm not going to get a very nice answer, but square root both sides, I end up with 17,4928, blah, blah, blah. There's a whole bunch of decimals. This is not my final answer, so I should not be rounding this off. However, as long as you keep at least 4 or 5 decimals, you should be okay. All right, so now I know that this length DC is 17,49, so on decimals. And now I've got all 3 sides of my triangle, so I can prove whether or not it's right angled triangle. Now, guys, remember, your calculator has stored its last answer. So your calculator still actually has the 17,9 blah, blah, blah value calculated. So when you go and substitute in, you just push the answer button, which I'll show you in a second. Okay, so that is my longest side. That would be my hypotenuse. So 17,49 to, what was it, 8? To 8, blah, blah, blah squared should be equal to 16 squared plus 13 squared. This is now converse Pythag because I'm trying to prove that this triangle is right angled. And just so that we know, we're in triangle DEC. Okay, so now this is where I would now use my answer button. So my calculator stored my answer. I don't know what I'm doing. This is clearly just like not my day. Hello, right, okay. It stored my answer. So I'm going to open my brackets, push answer, and then I'm going to square. And that will take that whole long decimal and square it for me and give me 306, which obviously we already know because we had it from CD. So 306 is equal to 16 squared, 256 plus 13 squared, 169. If we add those two values together, we get 512, which obviously is not equal. And so therefore, triangle DEC is not right angled. All right, so that was definitely a slightly more challenging question. You guys were flying through it, so I thought you deserved a challenge. I'll leave it up there for you to screenshot. just note that there were a few things that you needed to do before you could even get to the proving of the right angle triangle. Right, obviously you can see your poll is up there. Please let's answer it. Again, I will leave this up for screenshots. And then we will see you on Wednesday where we will wrap up this Pythagoras and then we move on to area and perimeter the week after.